All right, good morning, everyone. So this is our final week with inequalities. So what we've done so far is we've solved linear inequalities, we've looked at absolute value, we've done graphing inequalities, we've done systems of inequalities. So we're going to do kind of a review of that today. And then the next class we'll take the test and we'll be done with the unit. And then we'll start going into a review for the final exam. All right. So let's go ahead and get started. Although what I'd like you to do first, if you haven't done so already, is print the D-Day or do the D-Day. And when you're done with it, come back to this video and I'm going to go over some of the problems and I'm going to ask you questions about the problems. All right, and hopefully that'll allow you to understand some of the concepts that we're trying to learn in this unit. All right. Okay, let's get started. So for the first problem, what we do is we don't solve it directly like that. The way we kind of attack these is by making it an equation and then solving the equation. So we're going to add 4 to both sides and then divide by 3. So x equals 7. So I think some of us we're having issues with what to do with that. So that 7 goes here. That is my dividing line between the true and the false. In fact, my final answer is going to have that 7 in it. Now, to determine which way the sign goes, whether it's a less than or a greater than, I got to test a point. So what I've typically tested was 0. So if I plug 0 into the original inequality, 3 times 0 minus 4 over 17, I want to know, what is that, true or false? So is negative 4 greater than 17? No, it is not. That's false. So we write false here, and it gets shaded on this side because this is, remember, my dividing line. All right, and then what we're going to do is, this was an open dot. So it's going to look like that. So now I have a picture to go along with my equation here, or my inequality. All right, let's do the other one. Same thing. I'm going to make this into an equation. We're going to add 15 to both sides. 20, 30, 40 equals 10x. Divide by 10. So 4 equals x, or x equals 4. So either way, that 4 is going to go there. Again, the x and the 4 go there. I need to determine my sign. And notice it's a greater than or equal to, so I'm going to make a solid dot right now so I don't mess that up. So the thing is, I know it's going to either be this or this. So now I need to test a point. I'm going to test 0 again. So 25, plug 0 into here. This goes away. 25 is greater than or equal to negative 15. Is that true or false? That is true. 25 is more than any negative number. So I know I'm going to be shading in this direction. It's going to be a less than or equal to. All right. Now we have 2 more that are kind of like that. So I'm going to just continue on doing it the same way. Keep with my colors. Minus 2 from both sides. Divide by negative 3. So x equals negative 5. That's going to go here. I'm going to put that there. All right. I'm going to make my dot solid now, so I know it's going to be either this or this. I don't know which one yet. So I got to plug in 0. Now, don't forget, 0 is on this side of negative 5, so just be real careful with that. This goes away. So is 2 greater than or equal to 17? No, it's not. So I'm going to shade this way, because if that side's false, this side must be true. Right? So since I shaded in that direction, I'm looking at all my values that are less than negative 5. All right, let's go ahead and move on to this one. 9 minus 2x equals 10 minus 2x. I'm going to add 2x to both sides. You can kind of guess as to what's happening here. Things all of a sudden start to disappear. So what we have here is, this is going to be all real numbers and no solutions. So let's figure out which one it is. I'm still going to test a point. So on my number line, I'm going to test 0. So 9 minus 0 less than or equal to 10 minus 2 times 0. I guess this is 2 times 0. Either way, it's 0. These go away. So is 9 less than 10? That is true. So this is true. There are no sides to this. In this case, it's the entire number line. So my solution is all real numbers. All right, now we're coming up to a different type of problem. So, right, these are all inequalities. The first 4 were all the same. Number 5, these are absolute values. So what I'm trying to find is some value that will give me 11, right? And in this case, this value on the inside can be both positive or negative 11. So that's why I'm setting up both equations. The inside could be 11, or the inside could be negative 11, right? So that's why I have 2 separate equations here. 2x equals 12, x equals 6. There is one of my answers. I'm done. Add 1 to both sides. 2x equals negative 10, x equals negative 5. Done. Those are my 2 answers. All right, same idea. I'm going to ask myself, what could this be to give me negative 4? Well, we have a slight problem. Can I take, remember, absolute value means find the positive distance, right? The positive value. So is there any, by definition, I can't take the positive of something and end up with a negative 4. So because of that, there's no solution. And that's because when I take the absolute value of anything, it will be positive. But my answer they want is negative. So that's bad. All right, let's look at the other side. So these are graphing problems. So this is in standard form. When something's in standard form, what I like to do is just find 2 points, plot those 2 points, and connect my line, or connect the dots to make a line. So the 2 points that I'm going to choose, I can choose anything I want when I make a table. I'm going to let x equal 0. So 4 times 0 plus y equals 8. This goes away, so y equals 8. So I know my first point is 0, 8. Oh man, I'm going to run out of room here. So this is going to be 1, 2, 3, 4, 5, 6, 7. I'll just draw another line right there. That's 8. Okay. And then I can choose another point. Again, I can choose whatever I want. I personally am going to choose when y equals 0. All right, so I'm going to plug in 0 for y. 4x plus 0 equals 8. 4x equals 8, or x equals 2. So this is 2, 0. So this is going to get connected down. It's a solid line, right? Because it has this bar right there. And now I'm going to go back and test a point. So like I normally do, I'm going to test 0, 0. So I got to plug a 0, 0 into both of those. And I'm asking myself, is 0 greater than or equal to 8? No, that's false. If it's false on this side of my line, then this side of my line is my answer. So anytime you see an inequality, you know you're going to have a set of answers. It's not just one thing that will work, right? Or it may not be just one thing that will work. All right, let's go ahead and do this one. This one's like the good old days of beginning of the year, right? Start with the y-intercept, 1, 2, and then the slope is 3. 1, 2, 3, up 3 over 1, up 3 over 1. Now, if I wanted to, I could make a table for this, right? I mean, that's what you did in middle school. You made x 0, and then this is negative 2. You made x 1, and then 3 minus 2 is 1. I mean, if you kind of look here, you see these points popping up right there. And if I just went backwards, or 0, 2, and 1, 1, and I could put in negative 1, I end up with a point further down. Probably graphed a little sloppy. But anyways, let's finish the problem. So let's test 0, 0. So 0 greater than negative 2, that is true. So this side is true, which means this is the side that I shade. All right, and all of it's good. Again, what does the shaded region represent? All the points that make this inequality true. Okay, so now, after we learned how to do it just with one inequality, we said, hey, what if I had 2? What if I had a system of inequalities? So I do it the same way where I graph both of them, I shade both of them, but what I'm looking for is where they both overlap. So I'm going to call this equation A and do it in blue, call this inequality B and do it in purple. So the blue is -1, up 1 over 2, up 1 over 2, and then I get a line like that. I'm going to test 0, 0, 0 greater than, I know that's going to be 0, so I'm just going to not write it. So 0 greater than 1, that's true. So I'm going to shade up. For B, again, this is one of my table ones. I'm just going to quickly put out the table. So if X is 0, see, I can just kind of cover it up. I kind of see my answer, Y is 4. If Y is 0, I can cover that up. And I know X has to be 2. So I can get my answer pretty quickly that way. That's why I like to use that method. And then this is a dotted line because it's a strict less than. I'm still going to plug in 0. So 0 plus 0 is 0 less than 4. That's true. So again, my 0.00 is true, and it gets overlapped here. What I do want to note, what I do want you to do on your test is make sure that you make it very clear as to where your shaded region is. So just, you know, make it dark. All right. You don't want a mystery. You want to communicate properly. All right. Remember that shaded region represents all the points that make both of these equations true. All right, we didn't do very many word problems, but I bet you could figure it out. So if you quit on this one too fast, I'd like you to just take your time and think about this one. We have two conditions. All I'm asking you to do is write the system of inequalities. Cool? So you're going to get two inequalities right now. So Risa loves her baby and math. So right there you can tell baby and math are probably going to be your big topics. All right, in fact, she spends more than 80 hours a week playing with either one. So they're talking about the time she spends playing with her baby and the time she spends doing her math. Right, so if we want to define those, B equals time spent with baby, and M equals time spent with math. In fact, she spends more than 80 hours a week playing with either one. So the amount of time she spends with her baby and the amount of time she spends doing math has to be what? Do you think it's greater than 80 or less than 80? The key word here is more than. So the sum of these have to be more than 80. All right? All right, let's see if we can get the next one. Since she likes her baby better than math, she makes sure the number of hours she spends with her baby is more than the amount of time doing math plus 10. So the amount of, we can literally just kind of read it. Time spent with baby is more than the amount of time spent doing math. And they tell me what symbol to write, plus 10. So yeah. So the time spent with the baby is more than math plus 10. And that's it. You don't have to do anything with it. We just wanted you to graph it or just write them out. All right. Let's go on to number 11. So what's the difference between these two answers? We're looking at it. What does B represent? What does A represent? Well, I'm going to call this equation A, or don't do that. Let's call this equation 1 and equation 2. So B represents the solution to both equation 1 and 2. So what does that tell me about A? Yeah, A, this is B, A is the solution to only equation number 2. Because it's only shaded where number 2 is. Cool. All right, we have two more inequalities we're going to do as a system. These are written a little differently, but I don't want you to freak out about it. In fact, this is actually easier. So let's go ahead and grab this one. This one doesn't have a y-intercept. Well, it does. The y-intercept is not written. The y-intercept's 0. So we're going to have 0. So we're going to go up 1 over 2, up 1 over 2. I can go down one back too, right? Just to make it, I don't end up with a messy line. All right, that's my purple one. I need to shade, but what sucks about this is I can't test 0, 0. No big deal. Test a different point. So I'm going to test, let's test this point, 2, 0. You'll see why I chose 2 in a second. I'm going to plug in 2, 0 into my inequality. You see why I chose 2? What's half of 2? Yeah, I don't end up with a fraction. It just ends up as 1. So is 0 greater than 1? No. So I'm going to shape this way. X is less than 4. So I'm talking about my X values. So that's saying all of my X is always going to be 4. So 1, 2, 3, 4. It's going to be a dotted line. So all of my answers are going to be less than 4. That's what this is saying. I can actually just shade it like that. If you were to actually test a point, you could test 0. Is 0 less than 4? Yeah, it's true. So that's why I shaded that. All right. So again, my final answer, I'm going to get a darker pen, and I'm just going to shade it really dark so you can see what my final answer is. All right.